So we're back for the third part. One thing that Dr. Cho really loves about his wife is every once in a while she'll make an inappropriate comment. Everybody will stare at her, and then she'll say, well, I'm just saying what everybody else is thinking. And so I know what you're thinking. This lecture is damn long, and I know that, but to me it's kind of important to pound into you that you can actually do this, and that's what a lot of this lecture is about. But last time we left off about how can I do this myself? And so one big issue is space. Where am I going to get space? Well, a lot of startups started in the home, in somebody's garage. There's such a thing called share space, meaning you can get like a cubicle or something, have access to machines and conference rooms, and those cost you about $50 to $200 a month. It also gives you a mailing address to make it look like you're a real business. Warehouse and office space in the Phoenix area is about $1 to $2 per square foot per month, which is a heck of a lot better than Silicon Valley, which I think is up to 15. Ugh. And even if you want to do chemistry, you could pay $2 per square foot per month. So there's a lot of options for cheap office space in the metropolitan Phoenix area. Now, supposing I need lab space, meaning there are tools that I need and I can't afford it, meaning and not only that, but things like CNC and lathes take up a lot of room. Well, as it turns out, you can rent space in labs, meaning, well, if I do this work in a lab, do I lose my intellectual property? No, because you're paying them fees, and those fees are basically you are now renting that space for that time, so it belongs to you. And so you can also go with vendors. The thing about vendors is they don't care if you're a startup. They're out to squeeze you for every last dime. Trust me, I've been through one too many times. And there's also things you can do with vendors, though. Like one time I needed an X-ray source, and I was only going to use it for once, so I just said, hey, I'm thinking about buying one of your machines. Can I try it out? Well, yeah, I wasn't really interested in buying a machine, but I did get some free samples. Yeah, you didn't hear that from me. Anyway, software. If you want to learn how to do software, there are a lot of opportunities. Books, courses, websites will teach you for free. Why does Google want you to code? Of course I want you to code, because you're more likely to use their services. And of course, there's also school classes. Lots of opportunities. It all depends on how badly you want to learn how to code. And if you hate coding like me, you just find somebody else who can do it for you. Now, in terms of physical technology, I'm going to give you the secret. This is what all physical engineering is. You have a boundary condition. Remember Maxwell? Well, a lot of it's derived from his four equations. And that boundary equation is normally a boundary condition in differential equation is normally defines some kind of system, whether it's related to atoms, particles, or whatever. Next thing you do is come up with the design, and the design basically defines the dimensions of that boundary. Materials define the coefficients, and then you have a perturbation. You're creating some kind of change, and that's the active part of the boundary condition. And so then you do a whole bunch of math to solve it. Well, newsflash, people. This is, I better not tell the joke. Some of you out there might be Russian. But anyway, we have something called a computer. You don't need to do these calculations anymore. What separates engineers is their ability to problem solve. Because they want to develop the business. And Michael Dell, did he know anything about computers? Pfft, he was a pre-med major. Now, Michael Dell didn't come from an ordinary family, though. His parents were both businessmen. And so that's a whole different deal. But what it comes down to is if you outsource, you lose control of things. And so that impacts your speed. On the other hand, outsourcing brings in capabilities. There are pros and cons to it. I like to own it myself personally. So in terms of mechanical resources of the 5 parts I talked about, they're out there. If you want to design, ASU uses Autodesk, and Autodesk is pretty cool. I mean, if you have a little startup, you're not really bringing in money, they'll let you use it for free, but then as you grow, your fees go up. There are also all different kinds of simulators out there that don't cost you $100,000, which are more like $5,000. Lots of places you can find materials and parts. You can even find Amazon. Go ahead and type in Teflon. You can buy blocks of Teflon on Amazon. Machining and fabrication, it all depends on what kind of tools you want to use. Tech Shop has shut down in the Chandler area, but I know Jimmy Choi is trying to work to try to bring it back online. But they had a lot of these tools. Assembly is how you put things together. A lot of it's by hand. And if you need like advanced tools like shaker tables or stress meters or whatever, you can get that at the university. Now, in terms of electrical engineering, what is it that you need? You need computing, communications typically, your board level circuits, integrated circuits, and also some coding. And so how do I get those pieces? Well, the way I create an electrical design is I need circuit designs, I need to populate boards, I might have to do some coding, I might have to do some testing, whether it's I do it myself. Equipment today is so cheap. I mean, I outfitted a company once through eBay. And I think we spent under $1,000 to do it. And there are tons of publications that'll tell you how to do it. The IEEE is the largest technical association in the world with 425 members, 25,000 members. They have 39 societies. If you want to learn about something, you could just read one of their journals and they'll tell you. Not only that, but the vendors will tell you what's going on. DigiKey, Newark, they're some of the biggest part suppliers in the world. They have everything, everything in a chip. The big thing about cost is you're concerned about your bill of materials. Well, guess what? Everything you buy from them, they'll total it up and keep track of it for you, so you can figure out how much it costs in parts, and that's called the BOM manager. Not only that, but when I talked about communities, that's what they do. They give you designs. They have people talk together. They basically want to get you interested, so you go out and buy stuff. Here's an example, an accelerometer. They even give you a breakdown of how much it costs with volume. So naturally, if you buy a whole bunch of them, now your accelerometers are down to 62 cents. To buy one, it's only $1.36, and they can ship it immediately. This is the age of cheap chips. And as you can see, you can get a feel for with volume how much cheaper it's going to go. Not only that, they give you the application notes. They tell you exactly how to do the circuit. You don't even have to think about it. They tell you how to do it and how everything works. This is for a gyroscope. And not only that, but, I want to get a motor. How do I control a motor? You look it up, ta-da! They tell you exactly how. They give you the circuit and everything. Well, I want to do something wireless. Zigbee is a wireless protocol. Once again, they tell you all the parts that you need and what the values of those parts are. It's already out there for you. But how do I do my software interface? Well, it's not pretty, but it's cheap, and it's good enough for a prototype. National Instruments makes something called LabVIEW. What LabVIEW allows you to do is do the code, but you do it in such a way that's called graphical programming. You don't have to know all these if-then statements and global and local variables and all that. You just use icons. And so what LabVIEW does is you just draw what it is you want to code. For example, you want to measure the power threshold and the temperature threshold of a motor, and if it gets too high, you want the thing to shut down. So what you do is you define what that power threshold is or what that temperature threshold is, and based on what it's reading, because it's connected to a sensor, if it goes over in either case, the entire thing just shuts down. So all it is just pulling icons, basically dragging something out and then connecting them with wires. That's it. And this is also the beauty of National Instruments. Right now you're on their compiler. If you don't want to be on their software, they will convert it over into C++ for you. And it's not only that, but they'll also help you make the board. This is called a Rio. And the nice thing about the Rio is it's a nice compact way of testing, meaning all the power supplies and signals and everything else. It just comes out of this one little modular kit. And so you don't have to do all that testing. In terms of prototyping, just like with mechanical engineering, there are a lot of sources out there. Some of them are free and some of them are actually cheap. Now, of course, if you actually want something built, there's a cost to it. But it's all out there for you. And this is where you can go out and find it. Now, supposing I want to do something related to chemistry. I need materials. I'm going to need bench space because I'm talking about chemistry. I also need infrastructure. The thing about startups is you are not under OSHA rules. You don't have to fill out all those forms. You have to abide by OSHA rules, but you don't have to worry about the audit and filling out paperwork and everything like that. And then you have to deal with waste, and there are companies that will do that for you. In terms of computing, sooner or later you're going to typically need computing. Thing is, a lot of you are probably have heard of Raspberry Pi, and it has a computing power comparable to a cell phone. You can buy a used Raspberry Pi for $10. If you want something brand new and you want a shell to put it in, it costs $90. To get computing is dirt cheap. Now, here's an example of someone who actually did it themselves, and it was actually my goddaughter, and this was back in the 80s when they didn't have all these fancy schmancy kid stuff, and she wanted to know if her baby rolled over. She was worried about SIDS, and I said, oh, it's easy to build a sensor for that. She said, well, can you do it? And I said, I don't have time. And then the expletives flew, and I was the worst godfather ever, but I told her how to do it. And so I coached her, and she did some reading on her own. And keep in mind, she's a history major. She went out and bought the pressure sensors. I taught her how to solder, and that was pretty much it. She just followed the application notes. She debugged it herself. Not only did she so with the pressure sensor, a beep in life would go off if her child rolled over the wrong way. What did she have? She had will. How do I find people if I want to go the people route? Lots of different routes you can go. It's just a matter of how much work you want to put in. Now, what about my intellectual property? The thing about intellectual property, if they can reverse engineer it, if they could take it apart and figure out what you did, patent it. If they can't, then trade secret it. For example, I came up with the process. I found out that a 10-second water rinse was the difference between getting a 6 sigma yield, which is 1 failure out of 1,000,000, versus having a 3 sigma yield, which is 1 failure out of every 1,000. I actually had a guy at Ford yell at me because I wouldn't tell him what my secret was. But as it turns out, it was just rinsing it in water for 10 seconds. If you want more than 10 seconds, you have problems. That was a trade secret, not very obvious or difficult to find. So in summary, there are lots of resources out there for you to do this. What it comes down to is, even though you don't have a background, it's the will to do it and the will to teach yourself. And the thing is, there's no I can't in entrepreneurship.